Welcome to Lesson 9, titled Which Variable to Solve For, Part 2. In today's lesson, we're going to solve an equation for one of the variables. Our learning targets today, number 1, I can write an equation to describe a situation that involves multiple quantities whose values are not known, and then solve the equation for a particular variable. And learning target number 2, I know how solving for a variable can be used to quickly calculate the values of that variable. Our warm-up is 9.1, faces, vertices, and edges. In an earlier lesson, you saw the equation v plus f minus 2 equals e, which relates the number of vertices, faces, and edges in a Platonic solid. Write an equation that makes it easier to find the number of vertices in each of a Platonic solids described. So, the equation they give us is set up to solve for edges, because E is by itself. Now they want us to solve for vertices. So I would need to take the original equation, and I want to get V by itself. So I need to do the opposite of plus F, which is minus F. And I need to do the opposite of minus 2, which is plus 2. So now I would have V equals E minus F plus 2. And this solves for vertices. Now in each example, they're going to give us one of the missing variables. We're going to substitute that in and simplify. So here we have V equals E minus 8, because there's 8 faces, plus 2. Now I can combine like terms, and this becomes vertices equals edges minus 6. This solves for the number of vertices. I just need someone to tell me how many edges there are. And in the second one, they tell us edges. So vertices equals 30 minus faces plus 2. I'm going to combine the like terms. So it's vertices equals 32 minus the number of faces. Now, if somebody told me faces, I could solve for vertices. A Buckminster fullerene, also called a buckyball, is a polyhedron with 60 vertices. It is not a Platonic solid, but the numbers of faces, edges, and vertices are related the same way as those in a Platonic solid. Write an equation that makes it easier to find the number of faces a buckyball has if we know how many edges it has. So they want us to take the original equation and now they want it so that it's set up to solve for faces. If I want it to solve for faces, I need to move the vertices and the 2 to the other side of the equation. So the opposite of V is minus V, and I do that to both sides. And the opposite of minus 2 is plus 2, and I do that to both sides. So now I have faces equals edges minus vertices plus 2. And this solves for faces. Now, if I know there are 60 vertices, I can say faces equals edges minus 60 plus 2. I can combine the like terms. Faces equals edges minus 58. Now, if somebody told me how many edges there were, I could subtract 58 from that, and I would know how many faces there were. Our first activity is 9.2, cargo shipping. An automobile manufacturer is preparing a shipment of cars and trucks on a cargo ship that can carry 21,600 tons. The cars weigh 3.6 tons each, and the trucks weigh 7.5 tons each. Write an equation that represents the weight constraint of a shipment. Let C be the number of cars and T be the number of trucks. So I know that cars weigh 3.6 tons per car and trucks weigh 7.5 tons per truck, and that equals a limit of 21,600 tons. That's how we would write the equation for this constraint. For one shipment, trucks are loaded first and cars are loaded afterwards. Even though trucks are bulkier than cars, a shipment can consist of all trucks as long as it is within the weight limit. Find the number of cars that can be shipped if the cargo already has 480 trucks. So we have 3.6C plus 7.5 times 480 equals 21,600. 3.6C plus 7.5 times 480 equals 3,600. I would need to subtract the 3,600 from both sides. That would give me 3.6C equals 18,000. Now I need to divide both sides by 3.6, and C equals 5,000. So C equals 5,000 cars. Next, we have 1,500 trucks. So again, 3.6C plus 7.5 times 1,500 equals 21,600. 3.6C plus 7.5 times 1,500 equals 11,250. need to subtract 11,250 from each side. I get 3.6C equals 10,350. Now I divide by 3.6 on both sides, and C equals 3,125 cars. Now we want 2,736 trucks. So that's 3.6C plus 7.5 times 2,736 equals 21,600. 3.6C plus 7.5 times 2,736 equals 20,520. I need to subtract 20,520 from both sides. I get 3.6C equals 1,080. Divide both sides by 3.6. And I get C equals 300 cars. So lastly, they want the generic equation. 3.6C plus 7.5T equals 21,600. First thing I'm going to do is move the 7.5T by subtracting it from both sides. And then I'm going to divide both sides by 3.6. And my final equation ends up being the number of cars equals 21,600 tons minus 7.5 tons per truck divided by the 3.6 tons per car. And that would get me an equation that solves directly for the number of cars. For a different shipment, cars are loaded first and then trucks are loaded afterwards. Write an equation you could enter into a calculator or a spreadsheet tool to find the number of trucks that can be shipped if the number of cars is known. So now what we do is we take that original equation this time we want T equals, so we get rid of the 3.6C and we move it to the left. And to get T by itself, I need to divide the left by 7.5, but if I do that, I must divide the right by 7.5. So my final equation is that trucks equal 21,600 tons minus 3.6 tons per car divided by 7.5 tons per truck. Use your equation and a calculator or a computer to find the number of trucks that can be shipped if the cargo already has 1,000 cars. So T equals 21,600 minus 3.6 times 1,000 divided by 7.5. That's 21,600 minus 3,600 divided by 7.5, which equals 18,000 divided by 7.5, which equals 2,400 trucks. If we wanted to know when there were 4,250 cars, same thing, just replace the 1,000 with 4,250. .6 times 4,250 equals 15,300. That's 6,300 divided by 7.5, which equals 840 trucks. So our next activity is 9.3, titled Streets and Staffing. The Department of Streets of a city has a budget of $1,962,800 for resurfacing roads and hiring additional workers this year. The cost of resurfacing a mile of two-lane road is estimated at $84,000. The average starting salary of a worker in the department is $36,000 a year. Write an equation that represents the relationship between the miles of two-lane roads the department could resurface M and the number of new workers it could hire P if it spends the entire budget. So that equation would be $84,000 per mile plus $36,000 per person equals $1,962,800. That equation models this relationship. Take the equation we wrote in the first equation and solve it for P. So 84,000 M plus 36,000 P equals $1,962,800. First thing I want to do is get rid of the 84,000 M. So now I have 36,000 P equals 1,962,800 minus 84,000 M. Now I need to get rid of the 36,000 by dividing both sides. And I end up with an equation that solves for P. Now they want us to solve for M instead. So we use the same steps, just in reverse. I want to solve for M, so I'm going to get rid of the 36,000 P. Now I have 84,000 M equals 1,962,800 minus 36,000 P. But I want M by itself, so I divide by 84,000, and I divide both sides by 84,000. So I have a final equation of M equals 1,962,800 M equals 1,962,800 minus the 36,000 per person divided by the 84,000 per mile. So now we have our equations that solve for personnel and for miles of road. The city is planning to hire 6 new workers and to use its entire budget. Which equation should be used to find out how many miles of 2-lane roads it could resurface? Explain your reasoning. If we want to find out how many miles, we would use the M equals equation. This takes the number of new hires as the input and calculates the number of miles. Now they want us to find the number of miles if it hires 6 workers. $36,000 times 6 workers is $216,000. The budget we start with minus the $216,000 for new workers leaves us with $1,746,800 left. Dividing that by the $84,000 per mile is approximately 20.8 miles of road. Now they want to know how many people could be hired if the department is resurfacing 16 miles of road. So now we want to use the P equals equation. $84,000 per mile times the 16 miles equals 1,344,000. Now, if we take the original budget and we subtract the cost of the road, that leaves us with $618,800 to use for people. Divide that by the 36,000 per person. Is approximately 17.2. But we cannot hire partial people. So we would have to round down to 17 people. As if we hired an 18th person, we would go over budget. Now, if we wanted to know how many people could we hire when we only do 3 miles, we do the same thing, but instead of 16, we use 3. $84,000 times 3 miles is $252,000. That would leave us with $1,710,800 to spend on people at $36,000 per person. That's 47.5. But again, we can't hire partial people, so we would have to round down to 47 people. How many miles of road could be resurfaced if the department is hiring 2 new workers? So we go back to M equals. And we multiply 36,000 by 2. $36,000 times 2 is 72,000. And if we take the original budget and we subtract out 72,000 for new personnel, that leaves $1,890,800 divided by the $84,000 per mile. And that's approximately 22.5 miles. We can pave partial miles, so we leave that as the answer. And finally, if no new workers were hired, we substitute in 0 for P. Anything times 0 is 0. So we just divide the entire budget by $84,000 per mile. And that's approximately 23.4 miles. So our cooldown is on Kidam. This is 9.4 carnival tickets. The school is holding a carnival and hopes to raise $500. Child tickets cost $3 and adult tickets cost $5. If the school sells X child tickets and Y adult tickets, then the equation 3x plus 5y equals 500 expresses the fact that the school raised exactly $500 from ticket sales. Solve the equation for x. So we take our equation, 3x plus 5y equals 500. If I want to solve for x, I need x equals. So the first thing I'm going to get rid of is 5y. Now I need to get rid of the 3. So my equation would be x equals 500 minus the $5 per adult ticket divided by the $3 per child ticket will tell me how many child tickets were sold. And finally, explain when it might be helpful to rewrite the equation this way. If I wanted to calculate how many children tickets were sold when I know how many adult tickets were sold, this will take the adult tickets as the input and calculate child tickets as the output. We only have one glossary term for this lesson. Equivalent equations. Equations that have the exact same solutions are equivalent equations. If you are comfortable that you know your learning goals for this lesson, then you are on track for the test. If you still have questions, please bring those questions to class and get clarification from me before our next test. Thank you for your time.